Let's assume a set of solar panels on a rooftop. The sun is shining and the panels are working well, converting sunlight into electricity. The brighter the sun, the more the voltage. A controller is regulating the voltage from the panels, feeding the batteries with the proper voltage. Up to here, the system is DC. Unfortunately, chances are very high that the appliances you want to power are AC. You now need a device which will be converting your DC power into the AC necessary for your appliances to work. And that is the role of the inverter, converting DC into AC. We now know that if the sun is not available for a string of days, it might happen that your batteries get empty. In such a case, you will run out of power. The option for most off-grid systems is to install a backup generator. Generators are AC sources. They are compatible with your appliances, but they can't directly charge the batteries. Then, instead of using a conventional inverter, an inverter charger is more advisable. It is an all-in-one solution combining the conventional role of an inverter with additional battery charging features. Inverters come in three basic output types: square wave, modified square wave, and sine wave. Modified square wave inverters generally have good surge and continuous capability and are usually cheaper than sine wave types. However, some appliances such as audio equipment, televisions, and fans can suffer because of the output wave shape. Sine wave inverters provide a better quality power than the grid supply. When selecting an inverter, input voltage should correspond to system voltage. Output voltage should refer to the voltage supported by your appliances. You should also consider the waveform, output power, surge capacity, and stackability. All those information are found at inverter's specification sheets. All the DC components of an off-grid PV system, meaning the PV array, the controller, and the battery bank, must operate at the same voltage. We refer to it as the system voltage. The inverter input voltage is selected to match that voltage. Some appliances, such as audio equipment, television, and fans, can suffer because of the output wave shape. It is therefore important to collect information about any possible implication of the waveform on the loads before selecting an inverter. Additionally, we select inverter if they are capable of supplying continuous power to all this AC load. In that view, you should derate the inverter and take into account its efficiency. I would like also to mention that the inverter you will have selected should be capable of providing sufficient surge capability to start any load that may surge. The last point we will touch about inverter is stacking. Stacking inverters allow them to act as a single system. They will work together to charge batteries and provide power to loads. The advantage is an increased output.